Hello, it's Andy here, and today I am going to give you guys a brief introduction to how KiCAD works. So I think this is going to be a two-part video because of the way that KiCAD works, and I'll talk about that in a second. So if you want a refresher, KiCAD, I guess KiCAD, most people call it KiCAD. I've always called it KiCAD for whatever reason, but um, maybe I should start saying KiCAD. So KiCAD is a PCB editing software, and it is like the equivalent of CAD or like Fusion or SolidWorks for PCBs. And there's a few other ones that you might want to get familiar with, like Eagle. I think other teams in medical robotic use Eagle. And Altium is another one that a lot of people use in industry. So, but I think the principles that you'll learn here are very applicable to both of the other ones. So, I think it'll be a good experience. So, I'm going to give you guys a second to pause and download KiCad here. KiCad here. Yeah, and we'll return in 1 second. All right, so you've downloaded KiCad and you've opened it, and your window looks like this. So this is your basically your home screen. Usually you'll have your project on this side, and then you can click on any of these icons here to open the files in the project. So let's go ahead and make a new project then. So you're going to want to go to File, New, Project, and on this screen, it should open up a little um, directory folder for you to save your project in. So I'm going to choose this folder, and I'm going to name this KiCad Demo and enter. Okay, so when you create that file, you are going to get two files on your project side, project manager, I guess. And those are the PCB file and this SCH file. So that is SCH stands for the schematic, and before you even create the PCB, you're going to want to create the schematic. So the schematic is going to have all of the symbols for all of the components that you're going to want to put in your PCB, and you're going to want to define those first, define the relations to each other before you go into jump in and actually making and placing things on the PCB, because it will be easier like that, I promise. These are icons to basically do that. So this is the schematic layout editor. This one's the PCB layout editor. This one's called the symbol editor. We're going to talk about symbols in 1 second. And this one is the footprint editors. We might touch on that today, and we might save it for a part 2 video. So let's go ahead and open this schematic. So when you open the schematic, you're going to get this big worksheet. I think it's called a worksheet. I'm going to call it a worksheet because that makes sense to me. So on the right hand side, you're going to have the toolbar with a bunch of different icons. Don't worry if you don't know what they mean. I honestly don't know what all of them mean. So starting from the top, you have the selection tool. That's just this cursor here. There's two, like a crosshair on your worksheet for whatever. Highlighting net, so highlighting everything from wires to components to resistors and stuff like that. You're going to use this tool. Placing symbols, so symbols are anything that you're going to want to, are representations of what you're going to want to add to your PCB. So if I want to add a resistor to my eventual PCB, before I add a footprint, which tells you where it's going to go on the PCB, you're going to want to add a symbol of a resistor on your schematic. This one is placing power terminals. So PCBs usually have, not all the time, but usually have shared power sources at different points. So if multiple things want like 5 volts, you're going to have a single 5 volt input, and then you're gonna have that split to all the different places. Same thing with like a ground. All of the grounds, again, not all the time, but usually are connected. And then you have your wire. Wires are basic. It's pretty intuitive. It's just connecting things on the schematic. Buses can be thought of as groups of wires. If you have 4 wires going to the same place, you can use a bus. So first, we are going to, for this project, we are going to make a small PCB that has maybe a teensy on it and then a few LEDs to drive. So we're going to click this place symbol button, and we are going to click. So you're going to get this loading screen. It's going to wait for a bunch of libraries to load. And inside this, you can see that it has like a lot of different components that you can choose from. So the first thing we want is a resistor. So we're going to type resistor, OR, and you're going to get a lot of different results. So this, not everything here is very important, but one thing is, and it's this one here. This is the basic resistor. You can tell because all it says is resistor. So we're going to go ahead and click OK, zoom in a little bit, and click anywhere on the worksheet to place that component. So let's say we want to drive, let's have this thing drive 3 LEDs. How about that? So let's place one more resistor and one more resistor. Okay, there we go. Three LEDs driven with 3 resistors. So how about the LEDs? Let's go ahead and search LED. Okay, light emitting diode. That's what LED stands for. And place one of those. Place one of those. And place one more. Okay. You can right click and that will show you a bunch of different tools to use. It'd be nice if we had these LEDs pointing straight down so that they're parallel with the resistors. So let's go ahead, whoops, let's go ahead and go back to the cursor. Select all these, right click and click rotate counterclockwise. And perfect. So now we have the LEDs in line with the resistors. I think also you can use the hotkey R to rotate in that direction. But I just wanted to show you guys that. So, okay, now we can put these LEDs where they are meant to go. So this one goes here, and this one goes here, right under the resistors, right? So you'll notice that they come with a lot of text, right? So what is all this text? You can double click on any of the components to bring up the symbol properties window. So there is next to the resistor, there is some text labeled R question mark, and then there's some text labeled R. So R is that value that this is basically a placeholder for the value of the resistor. Remember, resistors are measured in ohms. So if you want a, let's say, I don't know, 330 ohm resistor, that seems pretty standard for our application here. You're going to go ahead and set that value to 330. So how do you know it's a resistor, or how does someone reading this know it's a resistor? Well, they look at this reference value. So typically resistors start with R, but what is that question mark? So the question mark is it's kind of a device used by the software to number everything. So right, we're gonna want to name each of these components, give them a different name, give them a different reference so that the computer knows what they're talking about. So we're not gonna worry about that for now. There's a pretty easy way to do that. I'll show you in a sec, but let's go ahead and change all of these resistors to 330 ohms. Footprint, we will talk about that later. 330 ohms. right? You can change the text alignment, what the text looks like, orientation. But for now, that's fine. We can just click OK. These LEDs, we don't have to change much here. They're LEDs, red, green, yellow, blue, whatever. We don't really care. Okay, so we are just going to keep that as LED. Reference D, D stands for diode, I believe, in this application. So again, it's fine. We can fill in the question marks later. Let's just go ahead and click OK. So now we want to wire this up, right? So to do that, we are going to click our wire tool, and then all we have to do is connect these. Oh, it looks like our text just moved. So that's not great. That's kind of annoying. But for now, let's go ahead and wire these up. So you'll notice that it goes in like basically all these directions. You can click an anchor point to have it anchored to that point to stop it from moving, to direct it. But this will serve its purpose for now. There we go. Okay, this little dot that's created, I think that's called a junction. Yes, that is called a junction. That just means that it's a multi-way connection. Okay, so now that we have our resistors and our LEDs, we want to drive them. Oh wait, actually, hold on. Let's move this text. I think we are going to, actually we can just not show it. Let's do that. Let's close one of these two. We only need one of them. That should be okay. We don't have to show that either, but let's just leave that. Okay, so now that we have all of this on the worksheet, we need a way to drive it. And remember earlier I said we are going to use a teensy to drive it. So let's go ahead and go into our symbol libraries and just search for teensy. Okay, we found the teensy here. I will say now that not everybody is going to have that teensy icon in their libraries. Teensy is a web downloaded library that I installed on my KiCAD. So let's go ahead and see how that's done. So let's exit this tool. To add a library to your software, you're going to go to Preferences, Manage Symbol Libraries, and here you're going to see Global Libraries. So Global Libraries is shared by all of your projects, and then Project Specific Libraries is just for this project. So if you want Teensy to be shared on all of your libraries, you're going to go ahead and add it to a global library. If not, go ahead and just add it to a project-specific library, and that will be fine. For this one, I have it in my global, so all the way at the bottom, you're going to see Teensy, and that means it's added, it's active, bam, that's good. If you want to add one, you are going to go ahead and click this button that says Add Empty Row to Table. You're going to give it a nickname. Let's just say for the sake of this, we call it Teensy 2.0. And then you're going to give the file path to whatever library that is. So if you were to go to Google right now, and you were to type in Teensy KiCAD library, you would get some results for that. So you can download it. I think this is where I downloaded it. This is the GitHub that has all of the files for, it says like all of these different Teensies from 1.0 up to, we're using 4.0, but go ahead and download all of those. And to do that, you just, I'm sure you guys know how to use GitHub. You just download this file right here, move it to whatever directory you want it to be in, and then put that directory here, that file path here, so that it knows where to grab that from. Okay, now that you've done that, we have our Teensy, and we have the rest of our circuit. So let's go ahead and connect these two up. One thing that might be good is let's go ahead and, oops, sorry about that. Let's go ahead and select this and rotate it so that we have a nice compact little circuit here. So remember that when voltage gets sent into these resistors, they have to output and loop back to ground. Since they're all connected, we only have to loop it back to ground once. You'll see on the T&Z that each of these pins has a name. So one is ground. These little numbers next to them tell you the pin number on the actual device. So these are pin 0, not to be confused with the pins that KiCAD gives them. I know that's kind of confusing and annoying, but you have to clarify that. So you have pin 1 on the or pin 0 on the T&Z, 1 on the T&Z, 2 on the T&Z, dot dot dot. So the good thing about T&Z, and the reason that we switched to T&Z, is that T&Zs, first of all, they have a lot of speed, but second of all, each of these pins with a number, like 0, 1, 2, 3, 4, 5, dot dot dot, all of these can be used as digital pins, as opposed to the Arduino, which has, or the Arduino Nano that we were going to use, which has, I don't know, somewhere around 20. This one has up to 40 digital pins. The text next to each of the pins tells you what each of the pins does. So RX1, TX1, that's transmission and receiving data. MISO, clock cycle, or chip select, sorry, CS is chip select. MISO MOSI, you'll see that a lot of this has to do with communications with other devices. And then we have the powers. So every here now and there you have the 3.3 volts, the grounds, the V-ins to power it, and stuff like that. So we want to connect this pin back to ground, right, to complete that circuit. So we can honestly pick any of these internally inside the IC or inside the PCB. They should be all connected. So let's go ahead and pick this one because it's the closest. And again, we want to use any digital pin to drive these LEDs, right? Because it's just an on-off, right? It's either on or it's off. So let's use these pins close as possible. One tip is to use pins that are contiguous, and by contiguous I mean like right next to each other, because that will make it easier to code, so you don't have to remember what pins, like count different pins. You can just remember, oh, it starts at 24 and goes up from there. Okay, so this should be everything we need to drive these three LEDs. So let's go ahead and go to the next step. So the next step is to fill in these numbers that we neglected before. And the reason that you leave it till now is after you have all your components placed, now is the time that you want to give them names, numbers, stuff like that. And that's because you're not adding any more components. You're not going to delete anything. Well, in theory, you can always go back and change things, but you don't have to, I guess is what I'm saying, go back and change things. So this is basically finalized to go to the PCB. So you're going to go ahead and click on this schematic symbol. It says annotate schematic symbols. And what this does is when you click annotate, you get a bunch of messages that say annotated LED or annotated 330 as R1, R2, D1, D2. So what that did is it named all of the symbols for us, so we don't have to go through by ourselves. You have R1, R2, R3, and they're no longer R question mark. Same thing with the T&Z. Now it's named U1 instead of U question mark. And we get a bunch of green messages here. No errors. Orientation complete. Looks good. Whoops. Okay. And go ahead and close that. All right. So next step you want to do is perform an electrical rules check. You don't technically have to do this, but it's probably always good practice to just make sure that nothing's wrong. Just make sure you don't have like, I don't know, something that would break. Like if you had like 3.3 volts connected straight to your ground, That might not be good. If you had like a open, like if you just had this wire hanging out, that also might not be good. So in that case, let's go ahead and click run, and we get our ERC, our electrical rule checker report. And it looks like we have 51 warnings and 0 errors. Okay, 0 errors is good. 51 warnings, let's go ahead and see what those are. So scrolling through the error list, it looks like all of them are because a pin is not connected. No connection flag to suppress this error, yada, yada, yada. Okay, so what does that mean? That means that each of these pins on the teensy that we didn't use aren't connected to anything. And KiCAD doesn't really like that, so they put this they're suggesting to put a no connection flag to stop this error. This is not going to break your PCB. It's just a warning. It's just a suggestion. I am not going to do it because I don't think it's necessary. Most people don't do it. So we can go ahead and close that. Okay, so everything looks good. Everything's connected. Everything's named. Now we have to generate the net list. So the net list is what is basically a list of coordinates you can think of, and the coordinates tell you that, hey, the teensy, the pin, this pin 37 is going to connect to this pin of R1, and then this pin of R1 is going to connect to this pin of D1, and then this pin of D1 connects back to ground. So when you go to the PCB, it's going to tell you, it's going to give you that list, and it'll tell you what you have to do to connect everything so it matches the schematic that you have here. So this makes it easier because you won't have to like be improvising anything while you make your PCB. Like you know exactly what you have to do. You just have to do it now. So generate net list, and let's save it in the project folder. Okay. Um, yeah, so now we have our net list. Now we can go into the footprint side of KiCAD, and I think that's a good stopping point for today. Next time we will go through and we will look at how to place components on an actual PCB.